Hello, and welcome to SuccessIRies, the infrared professional's choice for advanced training and continuing education. My name is Jim Sefrin. I am an Infraspection Institute Level 3 Certified Infrared Thermographer and Director of Infraspection Institute. I will be your host and instructor for the SuccessIRies short course. This course consists of an online narrated PowerPoint presentation and is one of several short courses offered exclusively through Infraspection Institute's iLearnIR distance learning program. This course assumes that the viewer is generally familiar with the science and application of infrared thermography. This course is provided as continuing education and is not intended as a substitute for thermographer training and certification. This course does not purport to address all safety considerations associated with the performance of infrared inspections. It is the responsibility of the viewer to become familiar with all safety requirements and regulations pertinent to his or her work and to take necessary precautions to prevent personal injury. In no event shall Infraspection Institute be liable to anyone for special, collateral, incidental, or consequential damages in conjunction with or arising from use of this training course. We thank you for choosing Infraspection Institute for your training needs and wish to welcome you to this dynamic and exciting technology. About Infraspection Institute. Before we begin today's course, we would like to take this opportunity to tell you a little bit about us. Founded in 1980, Infraspection Institute is the oldest independent infrared training and certification firm in the world. Infraspection's mission is to provide training, certification, and support for infrared thermographers. Infraspection is staffed by highly experienced Level 3 practicing thermographers. Our staff possesses decades of real-world experience in a wide variety of applications across a broad range of industries. Our experience and expertise are unmatched anywhere in the world. In fact, several of our staff are qualified as expert witnesses for legal cases. Infraspection Institute does not manufacture or sell infrared equipment, nor do we take commissions from the sale of infrared equipment. Because of this, our courses are presented without marketing hype. Our primary goal is to convey timely and accurate information to you, the student. At Infraspection Institute, we professionally promote infrared thermography through training, research, publications, software, and standards development. We are deeply committed to the promotion of thermography as a science and a profession. IR Info Conference. Another one of Infraspection Institute's training resources is our annual Advanced Training Conference and Technical Symposium, IR Info. We invite you to join us this coming January for the year's premier infrared event. At IR Info, you can enjoy 4 days of learning, networking, and fun in a relaxed yet professional atmosphere. At IR Info, you can enhance your credibility by learning new applications, hearing case studies, visiting our exhibitor showcase, test driving the latest equipment and software, and attending a wide variety of short courses. Our IR Info conference can also help to ensure your professional success. At IR Info, you can discover numerous business opportunities and learn how to increase your revenue and profits. At IR Info, you can also meet and share ideas with today's industry leaders. Our conference is well known for its family atmosphere and the willingness of our attendees to share their experiences with others. We are always on the lookout for speakers and presenters, and this year is no different. If you have an interesting tip, a new application, or a case study detailing how your company applies thermography or related NDT, we invite you to contact us. We have a number of incentives and can help you enhance your professional image by getting you the exposure you deserve. For more information, including special discounts or to register, visit us online at www.irinfoconference.com. This is SuccessIRies Short Course 101, Infrared Thermography, What's Hot in PDM. Thermographic inspections have been used for over 30 years as components in preventive and predictive maintenance programs. In the hands of a trained and experienced operator, a thermal imager can provide a wealth of information that can improve efficiency, productivity, and safety. With interest in thermography at an all-time high and equipment costs at record low prices, there has never been a better time to capitalize on the benefits of an infrared inspection program. In this presentation, we will explore some of the more common applications of commercial and industrial thermography. We will also discuss key considerations for implementing and maintaining an effective inspection program. What is thermography? Infrared thermography is the use of an infrared imaging system to detect, display, and record thermal patterns and temperature values across a given surface. The concept of thermography is simple. All objects above absolute zero, or 0 Kelvin, emit infrared radiation. While infrared energy is invisible to the human eye, it is detectable with a thermal imager, also known as an infrared camera. Infrared data can be observed in real time or captured to videotape, PC card, or electronic media for post-analysis. Today's modern thermal imagers are video camera-like devices which often can fit in the palm of your hand. A thermal imager converts the invisible infrared energy into a monochrome or multicolored image which represents the apparent thermal patterns across the surface of the object being inspected. When recorded on photographic film or paper, these images are referred to as thermograms. Many modern thermal imagers are also capable of recording temperature as well. Once captured, thermal images and associated temperatures can be stored for future reference and analysis. Infrared thermography is both non-contact and non-destructive. Infrared inspections require no interruption of service. Additionally, thermal imagers emit no harmful radiation and are completely passive. Why thermography? As we move further into the 21st century, companies will continue to face the demands associated with the global economy. These demands include increased competition both domestically and abroad. As the world becomes smaller, the number of competitors expands. No longer will it be enough to be the most competitive in the nation. Companies must strive to be the best in the world. In a global economy, companies must turn out the highest quality products in an efficient manner with less manpower while remaining profitable. Oftentimes, this requirement is coupled with the prospect of performing more maintenance tasks with fewer personnel. With these demands in mind, many companies are utilizing predictive maintenance technologies to help meet their objectives. While infrared thermography is one of the newest non-destructive technologies, it can help to provide substantial improvements in performance as well as tremendous cost savings. Other proven technologies include vibration analysis, oil analysis, and ultrasound, to name a few. Uses of thermography. There are many uses for thermography. These include, but are not limited to, preventive maintenance, predictive maintenance, condition monitoring, forensic investigations, research and development, and quality assurance. In short, thermography may be applied to any situation where knowledge of thermal patterns across a given surface can provide meaningful data about a structure, process, object, or system. Thermography is a growing field where new applications are constantly being developed. The use of thermography is often limited only by one's imagination. Common industrial applications. As stated previously, thermography can be applied to a wide range of systems, objects, and structures. Common industrial applications include electrical distribution systems to locate loose or deteriorated connections, overloads, imbalanced loads, open circuits, defective equipment, and symptoms of harmonics. Mechanical systems to detect excessive friction, misalignment, improper lubrication, and belt tension. Structural systems to locate water infiltration into building sidewalls and flat roof systems, detect building energy loss, and locate delaminations or voids in masonry structures. petrochemical refineries to identify missing or damaged refractory within boilers, furnaces, and kilns, and to monitor process equipment for proper operation. Research and development for numerous applications, including thermal profiling of printed circuit boards and components, as well as evaluating the thermal performance of a variety of industrial and consumer items. Electrical distribution systems. When it comes to reliability, few systems are more important to facility operations than the electrical system. Unscheduled downtime can be costly by interrupting production and idling workers while repairs are made. In some cases, electrical failures can cause catastrophic failures, including fires. Fortunately, infrared thermography can be utilized to detect incipient or certain types of acute failures within an operating electrical system. The theory behind this application is simple. Electrical current flowing through conductors and devices generates heat. Many electrical defects are accompanied by a rise in temperature. In some cases, this increase in operating temperature may be present for up to several weeks prior to a failure. Performed regularly by a trained thermographer, infrared inspections can detect a number of problems within operating electrical systems. Commonly detectable conditions include overloads, unbalanced loads, open circuits, inductive heating, harmonics, and defective equipment. Defective Air Switch Jaw. This is a thermogram recorded in a large outdoor electrical substation. We are standing on the ground observing two phases of a three-phase overhead disconnect switch approximately 30 feet above us. In this thermogram, we see a hot area indicated as white in the contact area of the left pole of the switch. This thermal pattern is typical of a loose or deteriorated connection due to the localized heating at the junction of the stationary and movable contacts. Although under the same load, neither the adjacent switch poles, which are represented in blue, exhibit this type of localized heating. Left unattended, this hotspot will continue to deteriorate until the switch fails, causing an unscheduled outage and downtime. By detecting this problem before it causes an outage, repairs can be carried out during a planned outage. Early detection also allows for the equipment to be repaired rather than replaced, since equipment damage is minimized when catastrophic failure is avoided. Deteriorated motor connection. Here we see a thermal pattern caused by a loose or deteriorated electrical connection within the junction box of a motor. Since thermal imagers cannot see through solid materials, the junction box cover has been removed to provide a clear line of sight to the connections. Because all of the motor leads are under the same load, we would expect even heating throughout each conductor and its connections. In this image, we see localized heating, shown in white, at one of the splices, which typifies a loose connection. Because thermography provides real-time data, this problem is identified in seconds without having to go through the time-consuming and destructive process of disassembling the taped connections. Correcting this loose connection prevents unscheduled downtime and can extend the life of the motor by eliminating voltage imbalances which increase motor operating temperature. Loose or deteriorated fuse clips. In this thermogram of a low voltage disconnect switch, we see excess localized heating caused by loose or deteriorated fuse clips on the left and right fuses. This problem is common to low voltage devices and can lead to an unscheduled outage. Here, early detection allows for a timely repair and also prevents damage caused by long-term heating of the switch components. With thermography, this information is gathered in seconds and does not require contact with the energized circuit. Improperly closed air switch. In this thermogram from an outdoor substation, we see localized heating within the jaw of a large air switch. In this image, excess heat is shown in yellow and white. Upon further investigation, it was found that the switch was not properly closed. If you look closely, you will see that the contact points on the switch arm are at the 7 and 1 o'clock positions rather than the 9 and 3 o'clock positions, indicating that the switch arm had not rotated fully. Overloaded circuits. This thermogram shows excessive heating caused by an overloaded circuit. Overloads are characterized by but excessive heating throughout the entire length of the conductor. Here, we see all of the conductors operating at the same temperature. However, they are warmer than they should be. Left undetected, overloading can cause premature failure of conductor insulation or lead to a fire. This image was captured during a quality assurance inspection of a new emergency generator system where the installed conductors were found to be undersized for the circuit load. Mechanical systems. For many facilities, machinery is the heart of production. Unexpected failures can interrupt production, idle workers, and cause widespread damage. Fortunately, infrared thermography can detect a number of problems within operating mechanical systems. As mechanical devices operate, heat is generated. Excess forces caused by friction, misalignment, or improper lubrication are accompanied by a rise in temperature. In some cases, this increase in operating temperature may be present for up to several weeks prior to a failure. Performed regularly by a trained thermographer, infrared inspections can detect a number of problems within operating mechanical systems. These include the ability to identify excessive friction and wear, detect misalignment in coupled systems, document over or under lubrication of bearings, pinpoint areas of refractory damage, locate underground pipe leaks, and monitor process heater or boiler tubes. In this thermogram, we see excessive heating caused by misalignment within a coupled system. Excess force caused by even the slightest amounts of misalignment can cause large amounts of excess heat on bearings and driven equipment. Such excessive heating can lead to premature wear and failure of the system, as well as higher energy consumption. In this image, we can clearly see the effects of misalignment. Excess heat on the pump on the left is shown in white. Excess heat is also noted on the motor bearing on the right. Detecting motor misalignment. In this thermogram, we once again see the excessive heating caused by misalignment within a coupled system. We see excessive heat on both the driven device on the left as well as the left side of the flexible motor coupling. Many maintenance professionals are surprised to learn that even the slightest amounts of misalignment cause large amounts of excessive heating within couplings. Such heat can lead to premature failure of the coupling itself, resulting in more frequent outages, more coupling replacements, and higher maintenance costs. Worn pillow block bearing. Thermography can also be effective in quickly identifying improperly lubricated or worn bearings. This pillow block bearing, located on a large paper machine, has heated to the point that it is actually causing the steel structure to become warm. Properly lubricated healthy bearings should operate close to room temperature. Once again, thermography can be performed quickly without interrupting production. Thermography is especially suited for remote inspections such as roller bearings on elevated conveyor belt systems. Steel transfer ladles. Thermal imaging is also useful in detecting thermal deficiencies such as refractory breakdown in large vessels. On the left, we see a refractory-lined steel transfer ladle at work in a foundry. The thermal image shows a uniform temperature gradient across the surface of the ladle with no pronounced hotspots. However, the ladle on the right is a different story. A large hotspot here indicates refractory breakdown within the lining of the ladle. Left undetected, a failure of the refractory can cause molten steel within the ladle to melt a hole in the ladle shell and release tons of molten steel onto the factory floor. In this case, thermography provides early detection that helps to avoid catastrophic failure and personal injury. Defective insulation on equipment. Insulated process equipment can also be inspected with thermography. In this image of an industrial drying oven, we see evidence of missing and damaged insulation, which allows excess heat loss from a section of the roof. Uneven heating in process equipment not only wastes energy, but can also lead to uneven or improper heating of the manufactured product. In some cases, uneven heating may compromise product quality. In this facility, thermal imaging is an integral part of reducing energy loss and maintaining product quality. Underground steam line leak. Thermography can also be useful in detecting leaks in heated or cooled underground piping systems. Here, we see a hotspot caused by a leak within a buried steam system located beneath a sidewalk. This infrared inspection is being performed at night from ground level. When a leak develops in a steam system, steam or condensate is lost to the surrounding earth. If the leak is sufficient for heat to reach the surface of the ground, the thermal imager can help detect the location of the leaking pipe. Detectability of pipe leaks is dependent upon several factors, including pipe construction, burial depth, operating temperature, and the amount of loss. Because thermography cannot determine the cause of a hotspot, excavation of the suspect area is required. However, thermography can help to eliminate unnecessary and costly excavation by directing efforts only to problem areas. Underground steam line leaks. One alternative to performing infrared inspections from ground level is to use an aircraft. Such inspections can be performed quickly for large areas such as industrial facilities or municipalities. This composite thermogram shows evidence of multiple leak sites in an industrial park. Here, leaks are indicated by the large amorphous shapes along the path of the buried steam lines, which are evidenced by the straight white lines. Infrared inspection of steam traps. Steam is an odorless, colorless, tasteless gas which is often used to transport heat energy within industrial facilities. In most facilities, steam is produced in a boiler or steam generator. Once steam reaches the desired temperature and pressure, it is piped to various locations where it is used. Once steam leaves the boiler, it begins to cool. This cooling causes condensate to form within the steam lines. As condensate builds, steam temperature decreases, causing more condensate to form. Left unchecked, this process will continue until all of the steam has returned to water. In order to maintain steam system efficiency, condensate must be quickly removed from the steam system. In order to do this, an automatic mechanical valve called a steam trap is utilized to discharge condensate while retaining live steam within the system. In this image set, we see three inverted bucket traps. Referring to the thermogram, the trap on the left shows no apparent temperature differential across the trap. This may be due to cycling of the trap or a constant leak. Here, contact ultrasound can be used to confirm the trap's operating condition. Improper fluid flow. In this thermogram, we see an electrical transformer with several cold cooling fins. This thermal pattern is indicative of an internal blockage within the radiator tubes. Such a condition causes the transformer to run hotter than its design limits and can cause premature aging and failure of the transformer. In this case, thermography quickly provides evidence of this condition without ever having to make contact with the energized transformer. Process heater tubes. Coke deposit. This thermogram shows a hot tube within a process heater used to refine crude oil. The white area indicates the presence of a coke deposit within one of the tubes. Left undetected, coke deposits can lead to irreversible tube damage and catastrophic failure. Thermography permits inspections to be conducted for heaters where visual inspections are not possible due to visually opaque flames. Other problems such as flame impingement on tubes and air infiltration into the heater can also be detected. Properly performed, infrared inspections of heater tubes can help refiners to increase product output while maintaining safety. Performed regularly, infrared inspections can identify problems in their formative stages. Structural systems. Infrared thermography can also detect a number of defects within buildings and structural systems. Under proper conditions, infrared thermography can be used to quickly and accurately locate energy loss, water infiltration, and certain types of structural failures. Common applications include roof moisture surveys, building energy audits, water infiltration studies, detection of concrete and masonry delamination, and non-destructive testing of composite structures. The thermogram pictured here shows a failed window unit on a commercial building. The dark area is caused by excess energy loss due to contamination of the space between the window panes caused by a defective seal. Roof moisture surveys. Thermography is also an effective tool for maintaining flat roofs. In this thermogram, warm areas, shown in pink, are caused by water trapped within the insulation layer of a flat roof. The concept of an infrared roof inspection is simple. When a leak occurs, water enters the roofing system and wets the insulation. In many geographic locations, this water will not dry out between storms. Once the storm has passed, the roof is heated by the sun. While dry insulation resists absorbing solar energy, wet insulation readily absorbs and stores solar energy. Once the sun sets, the roof cools quickly and uniformly, except for the areas of wet insulation. Because these areas have stored more solar energy, they will show as warm areas when viewed with a thermal imager. Performed at night, infrared thermography allows the wet insulation to be accurately located at the origin of the leak. Surveys may be performed from on foot or from an aircraft. Performed regularly, thermography provides data to improve roof system performance and extend the life of the roofing system. Energy loss due to misapplied insulation. Building energy loss can be readily detected with thermography. In this thermogram, we see misapplied batts of glass fiber insulation in a newly constructed metal building. This inspection was conducted from the interior of a heated commercial building during evening hours. Here, the dark areas indicate the absence of insulation. Although the insulation could not be viewed directly due to the presence of an opaque vapor barrier beneath the roof deck, the thermal signature of misapplied insulation is readily visible. In some places, only half of the required batts are present. In this case, the owner of the new facility was able to persuade the insulating contractor to correct the deficiencies, avoiding costly energy loss associated with substandard installation. Water-damaged insulation. This thermogram shows the exterior of a large condominium covered with an exterior insulated finish system, also known as EIFS. At the time of the inspection, the interior of the building was warm and outdoor air temperatures were cold. Following techniques similar to those used for solar-driven inspections of flat roofs, this inspection was conducted from the building's exterior shortly after sunset following a clear day. In the thermal image, we see large warm areas on exterior walls shown in pink. These pink areas are caused by large amounts of wet insulation within the building's exterior walls. The finger shapes are caused by gravity pulling the water down through the insulation within the wall. Research and quality assurance. Thermography may also be used to gather data for research and quality assurance. Thermography can be used to identify product problems, troubleshoot manufacturing deficiencies, improve existing processes, and to provide quality assurance of manufactured products. The yellow areas in this thermal image indicate a breakdown of the refractory bricks that line the interior of this cement kiln. Automobile defroster performance. Auto manufacturers are one of the many industries that regularly utilize thermography to improve the thermal performance of their products. Here we see two thermograms showing the effectiveness of an automobile windshield defroster. Thermography can help designers to correct engineering or design deficiencies before production ever begins. Customer satisfaction is improved and warranty claims are avoided. Engine testing. In the auto industry, thermography can also be applied beneath the hood as well. This thermogram shows the thermal pattern across the top of an operating automobile engine. Here, heat dissipation and thermal stresses can be evaluated for a new design. Tire manufacture and testing. Tire manufacturers also incorporate thermography into design and production. This thermogram shows a normal thermal pattern across a finished tire. Thermography can be used in design, testing, and evaluation, as well as during the manufacturing process to help ensure that products are free from manufacturing defects. Permanently installed online sensors can provide continuous monitoring of products, vastly improving quality control. Computer components. Printed circuit boards can also be inspected using thermography. Boards can be tested for proper operation, as well as ensuring that maximum temperatures are not exceeded. Starting an infrared inspection program. For facilities looking to initiate an inspection program, infrared inspections may be performed by in-house thermographers, outside contractors, or professional consultants. Because the thermographer is often the greatest limiting factor in an inspection, Thermographers performing infrared inspections should be qualified. To ensure success, thermographers must have an appropriate infrared imaging system and knowledge of the system being inspected sufficient to provide accurate diagnoses. They should also have proper certification training and experience, including an understanding of infrared theory, heat transfer concepts, as well as equipment selection and use. Maintaining an infrared inspection program. Businesses do not plan to fail. However, failing to plan can compromise success. In order to ensure success and longevity, inspection programs must be run like a business. When setting up an inspection program, following a few cardinal rules can help guarantee positive results. Always make certain to secure funding for equipment and personnel to perform and support the inspection activities. Promote and market your program to other departments to increase program visibility and participation. Follow published standards when conducting inspections. Document all findings with standards-compliant reports. Communicate success stories with others. Plan for future expenditures well in advance. And always know the value of your program at any point in time. Infraspection Institute provides a number of resources for thermographers and maintenance program managers. Our expert staff are always available to help you with solutions to your program challenges. Infraspection Training. At Infraspection Institute, we offer a wide array of training courses. These include Level 1, 2, and 3 Certified Infrared Thermographer courses. Open enrollment classes are held monthly and are open to the public. Upon request, Level 1, 2, and 3 courses may also be conducted on-site for individual companies or organizations. On-site classes allow for site-specific training and are often cost-effective for groups of 4 or more. Infraspection also offers several applications courses. Typically 2 to 3 days in length, course topics include, but are not limited to, infrared inspections of electrical systems, mechanical systems, building envelopes, roofing systems, and for pest detection. Customized courses are available upon request. Infraspection also offers several courses through our iLearn-IR distance learning program. These include Level 1, Level 2, and Level 3 Thermography, several applications courses, and our SuccessIRies continuing education short courses like the one you have just seen. For additional information on any of our training, we invite you to call us at 609-239-4788 or visit us online at infraspection.com. I'd like to take this opportunity to thank you for visiting SuccessIRies, the infrared professional's choice for advanced training and continuing education. Should you have questions regarding this presentation, you're welcome to email us at info@infraspection.com. We hope you've enjoyed today's presentation, and we look forward to seeing you again in the near future. Until then, I'm Jim Sefrin. Have a safe day.